Okay guys, welcome back to part 4 of Project Inc. Wow, I can't believe we're at part 4 already, but yeah, today we are going to be doing a couple of pipings and testing the MOSFET. So basically I added 2 extra switches over here so that I could test the wireless function, as well as these 2 MOSFET right here. These are MOSFET gates. They're controlled by the Arduino via a digital pin. So basically when the Arduino sends a high output, it opens the gate so that I could feed power through it. You have 2 terminals right here for each of these modules, and this side right here is your input power. So I have it pulling 5 volts into that, and that is feeding 5 volts into a line on the breadboard. So what this does essentially is a gate, or digital gates, and they're controlled by the Arduino via a digital signal, so that you're not feeding 5 volts or whatever voltage into your Arduino and back out to here. This is straight from the power, and the Arduino just basically acts as like a tap or like a switch essentially. I got those hooked up to these 2 water pumps. One of these pumps are going to be pumping water into something, and the second pump is going to pump water out of something, so that it'll kind of be a closed system, a closed loop system by the end of the video, or by the end of the project. I got them hooked up to 5 volts power right now. They are eventually going to be powered by the 12 volt rail, but I don't want to do that yet because they're not hooked up to anything. And inside these pumps, there is a rubber diaphragm. So if I'm running it dry, if I run it dry, then it'll damage or it'll wear out the rubber diaphragm in here a lot quicker, and I want to get the most use out of these pumps as much as possible. So right now I only have them running off of 5 volts. I have these 2 switches mapped to these 2 pumps. So let's see, this one, you see that one kind of vibrating, and you could hear it too. That's like, if you hear that, that's like a whistling sound, so it's sucking in air and causing it to sound like a whistle. For this one, so yeah, these 2 works. Now I'm going to have to hook up piping to these and hook up the check valve that I talked about in the earlier episode, and then test out the functionality of pumping water back and forth between these 2 buckets. Okay, so here is the vinyl tube I got last time. Here are the check valves, and I pick up a couple of these hose clamps that you could tighten down with a flathead screwdriver. And then for the vinyl tube, I'm going to cut it with this Husky ratcheting cutter. What I'm thinking is that I'm going to have about some length of vinyl tubing out, and then attach the check valve, and then the rest of the vinyl tubing will go down to those buckets, be like something like this, something like that, and then it goes down. Alright, perfect. Now we put on the hose clamp right at the input side of the pump. So yeah, that feels like a watertight, snug fit, but I bought these just in case. I'm going to clamp it down. Okay, so after turning it a bunch with a flathead screwdriver to the point where it can't turn anymore, turns out that it ended up being that this is not small enough diameter. It's not small enough to tighten this outer diameter. So I'm just going to abandon this, and hopefully this is good enough that it won't leak. Go ahead and attach the check valve. Here's how it should attach. So like I said, this tube right here, this hole, is the input. So we're going to plug it in. There we go. There we go. So yeah, let's do the same for the other one. Plug this boy in. got that check valve going into this tube, going into this pump. Okay, so now that I know that works, I'm gonna cut the other length DFE tube, the vinyl tube. The end enclosure is gonna be about 2 feet tall, so about 24 inches. So I'm gonna have to cut a tube with the length of 24 plus the 5 inches that I use for this, because these are measured at 5 inches. Okay, so I went ahead and measure out 5 inches for this length right here, and then another inch here for this gap in the check valve, and then from this line all the way down is 2 feet or 24 inches. So done with this one. I'm gonna do this one next. There you go. So that should be good. Okay, so we got those 2 pipes. Look at that. Impressive. Very nice. Okay, jump cut. I got everything set up for the test. Let me just walk you through it real quick. I rerouted the voltage input for these MOSFETs from the 5-volt rail here to the 12-volt rail, because these pumps are going to be running off of 12 volts. That also means I'm bringing out the 14.8 volt LiPo and plugging it into its own, wiring configuration. I moved the pump down here and got it into this sort of janky, sketchy setup, because again, I don't want water to be touching that and messing the whole project up. Added extension wires so that it could reach the power, and here goes nothing. Moment of truth. First, let's power on the system. Once I push one of these, it's going to start sucking water from this blue pail, this blue bucket, to that red bucket. Vice versa with the other button. So let's go. Oh. Holy shit. It's doing it. You hear that? Okay, cool. So now we know that the pump going from here to here works, which is this button right here, which is this switch right here. Let's go ahead and test the other pump, which should be pumping water from this tub to that tub. And that should be this switch right here. So yeah, I'd say this is a resounding success. I think I'm having an issue with these check valves causing too much of an issue with flow and overloading these motors. So what I might do is actually just remove them from the loop, because it seems like the water is staying where it is and it's not backflowing like I thought. So these pumps are pretty good at keeping water from backflowing, right? So these check valves might actually not be necessary, and if so, that would probably make it run a lot better. But yeah, I'd say this is a big success. Stay tuned next time for when we optimize the code and do a bunch of other stuff like LEDs and whatnot. Watch out for part 5.